Today's reading is Unit 1, Lesson 2, Exploration 2, Analyzing Patterns in the Number of Life Forms Over Time. Those of you reading the pages in the book, that would be pages 34 through 40. The fossil record shows changes in species and increases in biodiversity over time. It also shows the loss of certain species over time. When a species dies out, its fossils no longer occur in the fossil record. Scientists observed that the loss of species from the fossil record seemed to happen at a regular rate. Yet there have been time periods during Earth's history when the rate of species loss was very high. Identifying extinction events in the fossil record. Geologic time periods are identified by major changes in the fossil record. The site of this cliff in Palo Duro Canyon State Park in Texas includes the Permian-Triassic, or PT, extinction boundary. So that's the two different periods, Permian and then the period Triassic. The PT mass extinction happened about 248 million years ago. So in the picture, there's a yellow flag. That's a Coleophysis fossil, and they appear in the rock after the extinction happened. They were a genus of small meat-eating dinosaurs. At the blue flag in the rock is the trilobite fossils, which are found in the fossil record before the extinction, but they are not found after the extinction boundary line. So, in this photo, you have the Permian rock from the Permian era. You have the PT, the Permian-Triassic boundary, and then you have the Triassic rock. And so this dinosaur is found in the Triassic rock after the mass extinction occurred. This one is found in the Permian rock before the extinction occurred and is not found afterwards. So what it's asking you for question 12 is explain one inference you can make about fossils from the information in the rock layer. Well, based on the information that you see in this picture and what it's told you, the trilobites are probably about 248 million years old, because they know that mass extinction, happened 248 million years ago. So those fossils have to be at least that old. And also the trilobites probably went extinct during that mass extinction, because we have no fossils of them after this mass extinction occurred. Extinction. An extinction occurs when a species dies out and there are no members of the species left on Earth. The fossil record shows an extinction when a species is no longer found in sedimentary rock layers. For example, trilobites were once very common marine arthropods. They disappeared from the fossil record after the Permian-Triassic extinction, which indicates that trilobites became extinct. A mass extinction happens when whole groups of related species die out at about the same time. Mass extinctions appear to be caused by large changes to the environment. When so many organisms die, there are many new opportunities for surviving species to use ecosystem resources. Then they thrive and change over time. The number of new species found in the fossil record after each mass extinction eventually increases over time. So on page 35 is a chart. The 5 mass extinction events on Earth, and I'm just going to go through them in order from top to bottom. So at the top, the extinction event is Ordovician Silurian extinction, which occurred 443 million years ago. Proposed cause: rapid shifts in tectonic plates, climate change, which led to formation of glaciers that caused sea levels to drop. Organisms affected: up to 85% of all species. 45 to 60% of families of marine organisms died out. And then an organism that went extinct, the Orthoceras, went extinct, which is kind of this little worm-looking like creature right here. Late Devonian, 354 million years ago. Proposed cause: possibly a large comet strike, possible decrease in global temperatures due to dust and debris from the comet strike, drop in sea levels. 70 to 80% of all species were affected. Marine life affected more than freshwater and land organisms. So an example of an organism that went extinct was the Dunkleosteus, fish-looking thing. Permian-Triassic, 248 million years ago. They think it was caused by volcanic eruptions, release of methane from the sea floor, low oxygen levels in oceans, and then drops in sea levels. Largest extinction about ever that occurred, so far. About 80 to 85% of all marine and land vertebrate species died out, including all trilobites and many insect species. The Dimetrodon was one such species that went extinct. So this was the biggest extinction because there was a lot of land animals and ocean animals, water animals that died. Usually you get one or the other, or you'll get like one, but then you'll get partial of the other. You don't usually, if an event happens, it'll either affect the marine animals more, or sometimes an event happens and it affects the land animals more. There are those extinctions that affect both, but not quite as much as the Permian Triassic extinction did. And then next up is the Triassic-Jurassic extinction 200 million years ago. The proposed cause, it's poorly understood. They think it's possibly an extreme decrease in sea levels and lower oxygen levels in the ocean. About half, 50% of all species disappeared, and this was the end of reptiles that were mammal-like, leaving mainly only dinosaurs behind. So the Typothorax is an example of one of those mammal-like reptiles that went extinct. And then the last one they have listed is the Cretaceous Tertiary, which was 65 million years ago. So they believe this was caused by volcanic eruptions, climate cooling, drop in sea levels, large asteroid or comet strike. This is the mass extinction you hear about the most often because this is when the dinosaurs went extinct. Or not all of them, but a good chunk of them went extinct. Organisms affected, 47% of marine life, 18% of land vertebrates died, including non-avian dinosaurs, so like your turtles, your small reptiles, your birds, and your mammals were left. But your non-avian dinosaurs, like your T-Rex, went extinct. So the Quetzalcoatlus dinosaur, that's a terrible name. Quetzalcoatlus dinosaur went extinct during that time. So the question 13 asks you, mass extinctions are caused by global or regional environmental changes. During a mass extinction event, biodiversity in the fossil record increases or decreases. And the answers would be global and decrease. Mass extinctions are usually global because you're getting tons of organisms that are dying, not just like one species. So they're usually like the event that happened is usually happening worldwide. And then the biodiversity in the fossil record would decrease because a lot of species died, and then eventually like the biodiversity will increase after that event's happened. Turn the page. So then we're going to skip most of page 36. It's just comparing rock layers before and after mass extinction to estimate the number of affected species. They make estimates for the several rock layer samples, then they compare the loss of the species to the normal rate of extinction that happens as life changes over time. This would allow scientists to estimate the percentage of species on Earth affected by a mass extinction. The number of extinctions over time can be graphed, and these graphs show a relatively constant extinction rate broken up by large changes in the number of families of organisms lost during mass extinction events. So they have two charts. The top one is extinction rate over time, right here. And then at the different peaks would be your different mass extinctions. And then diversity of marine organisms over time. So it is showing you during these different extinctions what the biodiversity was of the area. So we're going to skip 14 and 15, but we're going to answer 16. And question 16 just says, mass extinctions do or do not cause permanent reductions in biodiversity on Earth. After each extinction event, the number of families increases or decreases rapidly over time, and the answers would be do not and increases. Mass extinctions, they happen. They've happened quite often in our history. They don't happen all the time, but they do happen, and it's not like it's wiping out everything on Earth. There are organisms that do survive the mass extinction event, so it's not going to cause a permanent reduction. It's going to wipe out a bunch of species. That is going to happen. It's going to reduce numbers, and that will happen. But it's not going to be like a permanent thing. It's an event that it happens, and once it's over, like, yes, it's wiped out a bunch of species, but eventually those animals will come back. Like, not the ones that died, obviously, but like they'll replace those animals with different species, or the species that survived it will multiply to replace those numbers. So you're not going to get, it's not usually, yes, it's a tragic thing that happens because, I mean, animals did go extinct, but at the same time, the like we've been talking about for all of our units, the last unit we're in ecosystem, ecology, and the environment. Ecosystems want to be in harmony, and so when species get wiped out, most species are very good about replacing those numbers so that the ecosystem can maintain and still be healthy. So the number of families would actually increase. The ones that survived would increase to take place of the ones that died. Patterns in extinction and biodiversity data. Scientists want to find the cause of mass extinctions. To do this, they analyze rock layers before, during, and after an extinction event. For example, when studying the Cretaceous Paleogene or KPG mass extinction, they looked at the rock layers laid down at the beginning of this extinction. They discovered unusual amounts of a metal called iridium in one rock layer in many different places on Earth. Iridium is rare on Earth, but it is common in asteroids. They also discovered tiny glass formations that are often found near craters caused by meteorite impacts. The high temperature caused by the impact melts sand. Glass spheres and other shapes form from the melted sand. Scientists use this evidence to infer that a very large meteorite struck Earth. It caused large-scale changes to Earth's environments. Large animal species were affected the most. Nearly all dinosaurs disappeared from the fossil record at this time. Fossil evidence shows that small mammals that could burrow to avoid the hot temperatures that resulted from the impact survived. It also shows that surviving species spread and diversified. Mass extinctions such as this are followed by periods of rapid growth in Earth's biodiversity. So then has a picture of an alphodon, which was a small mammal that survived this extinction, this KPG extinction. It likely did so by burrowing underground to avoid the dangerous conditions. So like your T-Rex couldn't burrow, so it would have gone extinct, but this guy, he would have survived. And this guy would have been, you can kind of see, he would have been an ancestor of like the common mouse or the common rat today. So question 17, if you observe the patterns in the plant diversity shown in the graph, how might species of flowering plants have survived the KPG extinction? So it shows you the age in millions of years, and it shows you like which ones had better survival rates than others. So this is the number of species, this is the time. So as time went by, as we get closer to today's time, it shows you how the numbers went up and down. So you have an angiosperm, those are your flowering trees, your cycads, your pteridophytes, your conifers, and your ginkgos. And that's just, they're classified, they have different names based on like what they look like and whether or not they bear fruit or have flowers and what their leaf shape is. So angiosperms actually increased after the mass extinctions happened. Cycads kind of went down, so did pteridophytes. Conifers kind of stayed the same. They decreased a little bit, and then ginkgos kind of went extinct, but they're coming back. So angiosperms are our most common tree and plant type. I mean, we have a ton of flowering plants nowadays. Sure. So how might species of flowering plants have survived the KPG extinction? Is what the question asks you. And the answer to that is just angiosperms have adaptations that help them to survive better in different temperatures. So if it's like super cold, their seeds are usually encased in flowers or encased in fruit, so they have a better survival rate. Same thing if it's like super hot. All right, turn the page. This is a lab model analysis of fossil record, and we are not doing this lab, so skip pages 38 and 39, turn the page to 40. Page 40, we're skipping, or we can read the engineering question. So computed tomography or CT scanners can give information about the inside of fragile bones, such as the skull of an early human ancestor. The CT images are a series of X-ray images that can be stacked to form a 3D visual model. These virtual models can then be used to make physical 3D models of either the fossils or what was inside them. So how can CT scanners solve the problem of damaging delicate fossils? Well, because you don't actually have to touch the fossil. Like, you don't actually have to open up the fossil to see what's inside. The CT scan will actually look inside the bone for you, so you're not going to damage it, because the X-ray can be somewhat damaging, but usually not to dead material. So the x-ray will be able to tell you what's inside and give you a more in-depth look of what that fossil looks like without actually you having to physically go in and cut that bone in half and risk it splintering and crumbling, because depending on how old it is, some of those bones, like if you handle them too much, they'll actually like disintegrate in your hand. So CT scans are a great way to avoid that happening. So then language smarts, explaining inferences from fossil record evidence. So ancient insects grew up very large during the Carboniferous period, about 320 million years ago. Scientists believe that this was due part to the air that was high in oxygen. Meganeura, I can't pronounce names today. Meganeura was an ancestor of dragonflies. It has a wingspan that was over 2 feet wide. So imagine a dragonfly that was probably roughly about this long with wingspan. Probably a little longer. Scientists have found thick coal deposits in Carboniferous rocks near Meganeura fossils. Coal deposits form the large amounts of decaying plant material. Such large amounts of plant material generally require warm and wet conditions. So then as a picture, Meganeura used its spiny legs to catch insects, lizards, and mammals living near ponds. Scientists think that insects grew so large because of the high oxygen levels in the air. So that's what it looked like. That looked like a dragonfly. Question 1 says, what modern organisms have an ecological role around ponds today that is similar to the Meganeuras during the Carboniferous period? Explain your answer. So large insects that live in the environment still exist today, like longhorned beetles. So Meganeura was also a predator of small animals. So like things that have replaced it nowadays are just other mammals. So like now we have, instead of having a large dragonfly eat like mice and rats, it's like foxes and birds, like owls. Question 21. Write a series of logical steps that you could use to infer the type of climate that existed during Meganeura's time. This is simply that the fossils are found in rock layers that have lots of coal deposits. Coal forms from decaying plant material, and since there's a lot there, so that means that there were probably a lot of plants during this Meganeura's lifespan. To have a lot of plants, it means usually that the climate is wet and warm, because majority of plants survive better when the climate is warm and wet. So that is all for the reading today. Make sure you check Google Classroom for your assignment and double check the calendar. The calendar will have the list of the assignments that will all be posted on Google Classroom, what days they'll be posted, and then the calendar also has the due dates for Black Day and Gold Day students. For science, you only have to do science the day you would actually have class. So if you're a Black Day student, you follow the grade highlighted days. If you are a Gold Day student, you follow the yellow highlighted days.